Welcome to the Actuarial Academy of East Africa Masterclass in AI. This is a 3-month practical program for practicing actuaries and also those who are on the path to become qualified actuaries. It is a course that's meant to enable those in the actuarial profession to be able to pivot to AI and more specifically to apply the fundamentals of actuarial science and be able to automate most of their processes and equally their thinking and how they are working with artificial intelligence. So this is just future proofing their career in artificial intelligence. This course is expected to take about 3 months, and we will be able to communicate the official start date, and it will run in 6 sessions, each of 2 to 3 hours, call it 3 hours, and weekly capstone projects to be able to evaluate the learners on what they've been able um, uh, to learn in the previous week. Dennis Kevogo, just for introductory purposes, and I'll be your lead technical mentor for this particular course or for this particular masterclass. I'm happy to be able to have you in this particular class, and I'll take you through today the intended learning outcomes and the curriculum roadmap. So on my screen, you can see the curriculum roadmap is that it will last for about 6 weeks. The actual labs, and then we'll have another 6 weeks or rather 6 sessions whereby I'll be expecting you to work on your capstone projects, and then we'll be looking at the output together and then reassess on whether the learning intended outcomes have been met or not. So for week 1, we'll be covering the generalized linear models to machine learning. End to end, we'll look at supervised machine learning, unsupervised machine learning, and equally reinforcement learning. Remember, reinforcement learning is the build up now to agentic AI, where we are at today. And that's why you can see we are starting from the very basics all the way now to AI. We'll then move to look at the risk class. So herein, we are trying now to marry the actual profession to artificial intelligence. There are some of the models, just the foundational models that we are going to look at. A good example is XGBoost, which is a part of the bugging and boosting algorithms. So do not worry. We'll be able to make it easier for you to understand as we move by. And then we will move to deep learning. So just to keep in mind that we have artificial intelligence, and then machine learning is a subset of artificial intelligence, and then deep learning is a subset of machine learning. So deep learning is where models use a technique called, or an algorithm called neural networks to be able to train a model to think and act like a human. So deep learning has two subsets. One of them is what we call convolutional neural network, which actually trains and pre-trains images and videos. And then on the other side, we have RNNs. RNNs now deals with text, and that's why you can see one of the use cases would be in IBNR, which is part of what we're going to cover. So within RNNs, we are going to focus on two of them, that is gated recurrent units, as well as long short-term memory. So long short-term memory, that is the genesis of LLMs today, large language models. It started off with long short-term memory, which then mutated to what we call self-attention mechanism, learning by itself, that is recursive learning. And that then led to the building or formation of transformers, which then again has mutated now to what we call large language models, where we are at today. So that will form a good basis for us now to move to week 4, which is generative AI, where we'll be looking at large language workflows. I'll be able to measure and understand your technical depth, and I'll be able to hold your hand to make sure that then we're getting the most out of this. And it's my endeavor that you can be able to do, or actually do, what we call LLM calling. Basically, can you be able to create an API key from OpenAI, create an API key from Gemini, and run it through the models, the actual workflows that you're building, without necessarily building a retrieval augmented pipeline from scratch. So a retrieval augmented pipeline, generative pipeline, simply means that you're trying to build your own foundational large language model within your organization using your own data, which is can be quite complex, can also take a lot of time, but a RAG pipeline would have what we call contextual awareness of the organization data as compared to an LLM call. So therein, I would expect you at least to be able to, in a very simplistic way, build your own large language workflow, but primarily within the actual workflows that we are looking at. And then we will move to the governance perspective, which is also quite fundamental. We'll look at explainable AI and bias, which is very important today. Artificial intelligence is at a stage called artificial general intelligence, which is the basics. Not much of it has been exhausted or achieved before we move to narrow artificial intelligence, but there's a lot of leeway for mistakes, errors, and actually we need to have proper ethical considerations. So I'll run you through a few governance frameworks that have been developed, especially by the federal state, such as NIST. We'll also look at the EU Act, but most importantly, how is it applicable to a business or to your business or to your work on a day-to-day basis. I will also run you through how to build a framework of guardrails and also understand the difference between an AI governance framework and an AI policy, and which policies perhaps would form a most important conversation within your organization. We then now move to strategy, and under strategy, again, we need to build confidence in you on when to buy and when to build. We've seen instances within organizations where people have been able to buy models and they do not realize the most value of it all in, say, a year or even 2 years. And that is what we call artificial intelligence decision clarity. Can you be able to stand in the gap for the organization and be able to become an AI leader? And this AI leader is one who can be able to also define and calculate what we call artificial intelligence return on investment. So a build up on it is now a final capstone project that should be able to guide you through this particular course. So week 1 and week 2, the learning, or rather week 1, if I may look at it that way, systematically, it's the new frontier, and I've touched a bit on it. What learners would be expected to gather from this or get out of this is the evolution of GLMs to machine learning. So remember, the genesis of machine learning was actually linear regression, which is now what we have here as generalized linear models and its own assumptions and the build-ups. And then we look at AI hype versus regional reality. We'll plug in some use cases and analogies from Gartner and Microsoft globally on what's really happening. I know the conversation of the AI bubble has been in the streets as we speak today, and even AI slope. Some companies are already realizing an AI slope because they invested a lot of money, but they are seeing no returns. And now they are realizing that AI is actually not what they thought it was. They thought it's some sort of total game changer, but AI starts from the question of data quality. That's the foundation. And then it moves to talent. And then now it moves to you bringing in infrastructure to support AI quality. We'll also have some vendor independence labs, basically just to be able to run you through a decision matrix on when to buy and when to build, and when not to buy and when not to build, and which is very important. And then we'll also have what we call a model inventory audit. I'll be able to run you through what we call AI artifacts so that you know how to build, for example, a model risk office to assess your AI models, a sandbox environment, and then thirdly, also, can you be able to build your own AI governance framework, a risk register? So those are some of the artifacts that at least should have a capability after the end of this particular session to understand. The learning outcomes is to understand why the model inventory matters more than the tools, quite important, and then differentiate between hype and practical value within this particular region and even globally, and then transition from traditional GLMs to adaptive machine learning frameworks. We then move to week 2, where now we are trying to to bring in risk classification. And I'd expect us to be able to practically build a machine learning model using XGBoost and LightGBM, and especially where we are looking at sparse regional data. There are a number of data sets that we look at, but this is at the core of modern actuarial pricing and classification, especially for high performance supervised machine learning models. I'll help you understand the difference between supervised and unsupervised machine learning models. But primarily a supervised learning model, your variables have been labeled, and especially your target variable has been labeled. So you know your target variable, and the other variables have also been labeled. But unsupervised, the target variable has not been labeled, so it's learning by itself, and then it's going to predict. So that's part of what we're going to cover within week 2. We'll then move to week 3 and 4, where we'll now be looking at advanced applications and workflow automation. And herein, I'll expect us to at least cover neural nets or linear networks for IBNR and telematics. We will not move quickly from the good to the excellent, not at all. We'll be able just to walk you through baby steps so that you have an understanding of the basics of advanced workflows in AI. And quite interesting, even before we move to LLMs, it's important you understand the evolution of LLMs and how we moved from RNN all the way to LLMs, and how you handle sequential data, which is text, and that's why LLMs were built for. Then we'll look at LLM abstraction layers. I'll walk you through all the transformer architecture and the LLM, the different layers, and how you build it on. Please do not be scared. I'll be able to distill this information. I'll make it easier for you to understand all through time. So today we are in the era of loop engineering, even forget about prompt engineering. I'll enable you understand, and we will, again, like I've mentioned, walk baby steps to make sure that we are all at par. The skills you're going to come out with is time series forecasting with recurrent neural networks and long short-term memories. So long short-term memories, as I've mentioned, is just one of the algorithms under RNNs. And then automating routine actuarial documentation. So remember, this has also to come from you. Largely, you're the subject matter expert in actuarial. That's me, SME in actuarial. So mine is to come and augment your work every other day. And then we'll look at integration of usage-based insurance. Again, like I mentioned, we don't want to move from the good all the way to the excellent. We are going to make baby steps so that we are intentional about what we are learning. We'll then, of course, just have a use case, 1 or 2 use cases on an LLM workflow and efficiency through automation. I'll try to introduce one or new tools that maybe you've interacted with or not, but the key prerequisite is at least you can be able to interact with Python. I know we are more inclined towards R, but I'll make it a little bit more comfortable, because with Python, we have a bigger community, and the contribution is also much larger. So it's easier to interact with, and even the learning curve is easier. So some of the prerequisite other than that is just you are well acquainted with simple AI terminologies, like LLM, like SLM, like a small language model. What is it? Just largely. But the output is what matters the most. Can you be able to do something like prompt engineering? Do you actually understand? What is the logic behind it? And in every other aspect, can you be able to solve a business problem? You've been given, or you have a cost function. Can you be able to reduce the cost function? Basically, you have your constraints and you have your variables, your decision variables. Can you be able to interpret what a negative constant is and what a negative constant is in the business context, and apply artificial intelligence to be able to solve a problem? That is it. We always look at the objective function and the cost function. That is what matters for the business. We'll then move to week 5, 6, where we are looking at compliance, ethics, and regional roadmaps. Regional roadmaps, that simply means, remember we have now what we call multi-market AI. AI in Uganda is moving at its own pace. AI in Kenya it's the leading and the second in Africa, slightly behind South Africa. So, I mean, that is at least from my own assessment and what I've been able to gather around. But most importantly is, can you be able to see the roadmap of even the data protection Act and privacy regulations in Tanzania, in Kenya, and that applies to organizations such as ZEPRI as well, which are regional organizations. So that is the key output here. But again, an important analogy is for you to understand that we do not want AI to be a black box solution to an organization or to yourself. We want you to understand what's going in and out within that particular model that you're building. Otherwise, there'll be giggle and you might not get the most output of it all, and you'll go back to an AI slop. Oh, okay, fine. I didn't even gather as much as I thought I would as a skill set. So there are two techniques that I use to be able to do what you call model explainability and interpretability. For you to solve the black box solution, you need to make sure that your model is explainable and is also interpretable. So we have Sharp and Lime, where Sharp looks at the global feature importance values, and Lime looks at the local surrogate model explanation. We'll be looking at the global minima and the local minima. So those are some of the concepts that you're going to learn as we move by. But most importantly is for you to understand explainability, transparency, and interpretability. And I'm happy to build your capacity in the same. So remember, and I repeat, we'll be doing these in baby steps, so it shouldn't really scare you. That will become consumable as we move by. And most importantly, in one of the sessions, I'll be able to invite an AI governance policy expert who has built a number of governance frameworks in Geneva and even in Kenya and South Africa, to be able now to give us the policy side of it as a policy expert. How does it look like? And what does it mean for the business and for you as an actual professional? And then mitigating risk, which is also important part of what we shall also capture, and where we are at today. Importantly, also capture some use cases, what has happened locally and internationally, and some finds that you could be fined a lot of money, especially in the context of personal identifiable information in case it's leaked. Last but not least, we'll now cover the local implementation, just understanding the different acts. I think by it is what is the difference between the act here and the act in Tanzania and even the global acts, the GDPR. Remember, most of these acts and laws have been borrowed from the GDPR, the General Data Protection Regulations. The 7 principles, including transparency, confidentiality, all those have been able to be cascaded down these particular 3 acts that you can see. But Kenyan Act, you can see it's focusing on automated individual decision making as far as AI is concerned. And then Uganda is strict cross-border data transfer controls. And then Tanzania, mandatory registration of AI data controllers. I mean, like I said, it's a learning process and we're in the experimentation phase. So it's just important we also see what's going on. So the mastery in the outcomes is you have technical depth, you also have a strategic mindset, and you can also have an operational angle to it. Thank you so much, and I'm looking forward to having a successful interaction with you all. Thank you.